This session is covering your test bases, practical strategies, tools and tips, but I'm really going to be highlighting the practical part. A lot of experience that people have in this area of engineering is very theoretical. You shall do this. I use the word shall very specifically. But what I'm going to try and leave you guys with today is more of, here are the theoretical things. Let's cherry pick and choose a few bits and pieces that provide the most value for your organization as you're going forward. My name is Christopher Relf. Call me Chris. I'm the Chief Architect at VI Engineering. We're a National Instruments Platinum Alliance partner, which is the top tier of the Alliance partners. Our headquarters is in Detroit, Michigan, which is where I'm based. You can tell by my accent. I'm obviously from Southeast Michigan. We have a bunch of certified LabVIEW architects, test stand architects. We've been working with National Instruments for about 25 years now. We started mostly in automotive, being based in Detroit initially, and then about 15 years ago, our president at the time, Bob Jacobs, our founder, diversified the company, and most of our work comes from health sciences, medical, military aerospace, and consumer electronics as well. We are a test system provider, so we can do anything from R&D, startup, test strategy, assistance, all the way to turnkey systems. Some of our success stories, you can do anything from coming in and helping a startup think about what they should be testing right now in their R&D phases, and then when they think about scalability towards the production end, so you don't end up wasting too much money at the start, and you can leverage the stuff you use at the start when you actually go into production. We do a lot of our work with contract manufacturers in China as well, so your Xbox controllers and all those really essential items that you need to have in your home that go through 100 lines in a factory in China, where we have a lot of presence over there working on test systems for their line. So we do a lot of custom stuff, but we also have platforms as well, hardware platforms, software platforms, but that's not what this session is about. Who is this session for? The answer is everyone. No. Because of the diverse roles that people have that come to NI days, we're trying to really hit three target demographics. The product managers, who are concerned about their product and making sure that it's been made right. The test infrastructure managers, who are the people that are responsible not for just one test line or one test system, but generally multiple test lines across a facility or multiple facilities. And the test engineers. And we're kind of more focused on the here and the now, or the one product or the one test system, and hopefully some of the stuff you're going to learn about today is how to integrate some of those strategies and philosophies across different test systems, so that you don't go to sleep during the session, or so you can schedule when you go to sleep during the session. I've included these little icons down here. If yours is in color, you should be taking notice right now. If it's kind of grayed out, fades out a little bit, I'll be fine with that. Real quick, let's talk about some development models. Everyone heard about the waterfall development model? Anyone using it? 3, maybe? Pros, more time spent up front. You have the assurance that your requirements and your design are 100% done before you actually do any kind of development. So hopefully there are no surprises along the way. You have concrete progress throughout the life cycle because you've got it pegged to these different points in the life cycle. Your phase output verification is inherent in every phase. You have these gates where you're like, all right, requirements, done with the requirements, now we can move on. And your life cycle milestones are determined up front. Cons, there's no method for revisiting a phase that's already existed. Redesign is certainly problematic, and I'll talk about it in a sec. The overall project lifecycle can take much more time because you're spending a lot more time up front with the what-ifs in your mind and a lot more engineering anxiety. And the business value is delivered all at once at the very end of the project. There you go, customer. Enjoy. Hands off. Iterative development models, and I include things like Agile in this guy here. People, show of hands, people that are using iterative development mod, about the same. This one's a lot of fun, but it can be really stressful too. You have the ability to learn from previous iterations to be able to push that into new iterations, and you iteratively, as you step through the project, as you're learning things, you get to build and build and build. Portions of the business value are delivered at each iteration, so traditionally your customer actually sees progress, real tangible progress. It's not just, we're working on stuff, it'll be fine, call us in 2 years. Your architects tend to work 1 step ahead of the developers, so your developer's backlog is always full, or close to full. And the business value traditionally is closer to what the customer actually wants because they have more possibility to see what you're doing as you're doing it and provide feedback while you're developing, so they don't wait until it's too late. Cons, it's difficult to predict when the project is fully complete. Because you have that loop to go around, it's really easy to just keep on going around. Even when you've provided most of the value to the customer and then they say, you know what, that red stop button, can you make it a little bigger? Can we put it over there? I like round ones too. And you're like, all right, let's go around the circle again. That's a trivial example, but it certainly scales. And it typically takes more time to complete a project, but not always. If you have a team that is very militant in the way that they use this kind of model, then it can be a really good fit. V model. Who's using the V model? 2 people. Okay, so we've covered about 10 people in the room. What's everyone else using? Ad hoc, code by the seat of my pants model. A combination of all of them? Excellent answer. So V is the one, the shining bastion on the hill that we've all been told to follow in the last 15 years. It's the one that everyone's been most excited about. Agile is taking that over, which is a story of its own. V model, your pros is you ensure that you do testing at each output during the project. So essentially it's a waterfall, but with testing. There's a higher chance of success over the waterfall model because you do that test planning earlier on in the life cycle. The cons is that it's still pretty rigid. You still do your requirements, you still do your design as small modular chunks. And because you're not doing that iterative development of those sections, the feedback isn't going back up the left side of the V so much. So what I want to do in this session is to talk about how to cover your test bases, how to determine what to test, how to determine when to test. And to do that, we really need to step back and take a look at the big picture. As test engineers, which most of you here are, we're really concentrating on the here and the now. We're concentrating on that next API or that next module that I'm writing or that next UUT that I'm working on. But what I need to challenge people to do is to step back and say, where am I in this guy? This is a product life cycle where you start in the middle and you've got this great idea and you're moving around these different quadrants here where you determine your objectives, you identify and resolve the risks, develop and test, find the next iteration, and you're going around this cycle. It's kind of like a really zoomed out version of Agile without the throwing away stuff so much. So you need to know where you fit in here. You need to know, all right, am I working for the R&D portion of my company? Or am I working for, hey, we're setting up production-based test systems that are going to be spewing out 1 million units a week? Because the way that you choose, or what you choose to test and when you choose to test can be very different. It's also important to know that if you are further in this part of the spiral, more in the R&D prototype phases, how to choose what to test that can then be leveraged further out the spiral. So can I design my test or can I pick what to test? It's important in R&D that then can be leveraged by someone who is actually in production test because then it's more overall value for your organization, more overall value for your customer as well. A neat little graphic that kind of illustrates that. So you start with your modeling. We're now stepping outside the spiral a little bit. Prototyping, initial product, final product. There's actually an extra one on top of there, which is more warranty testing, warranty returns, and what have you. And traditionally, what most of us think of as test engineers is we're in this test band over here. We may be at the R&D portion, or we may be at the production portion, but we're in test. And the answer that someone came up with earlier when I asked what other models are people using, it's a combination of both, is the perfect answer. Because when someone says to me, I developed using the Agile model, they're not correct. They may use it for part of their process, but they're probably using the Agile model within one step of another model, and they're probably using that model with one step of another model. There's a great quote by Jeff Plotsky at NI Week 2005 or something like that, I think, where he said, models can and should fit inside other models. So what I'm trying to do is break you out of the idea that I have a model, I develop to the V model, I do my requirements, I finish my requirements, I do my development, I finish my development, and say, you know what, when you're doing development, you're probably doing some Agile stuff, you're writing some VIs, you're running your VI and changing some inputs and checking the outputs, do they work, do they not work, all right, we need to rethink how I did that, change things a little bit more until I get the answer that I'm actually looking for. So it's important to be able to step back and look at the whole landscape of what you're trying to do. Okay, so now we're actually going to talk about things that you can do. Before I dive into this too much, another common fallacy is that you need to do everything. You need to do everything really well. There are so many different industries and so many different industry standards for this kind of stuff that when you're working with the V model, should you do perfect requirements every time? Should you do perfect design every time? What you need to do is step away from that and say, what is of value to me? What is of value to my company to execute this project, and what is of value to my customer? An example might be requirements. We're all told that we should write them and they're super important so that we have some kind of baseline going forward. But there are times when requirements aren't really required. For example, when a customer comes to you and they've got a really well-written specification that you can mostly use as your requirements document. You may choose to augment that a little bit with some kind of addendum to clarify some of the things that are in the specification. But you don't necessarily have to write your IEEE 9001 traceable requirements unless your industry requires it, you require it, or your customer requires it. I want to let that sink in a little bit, because as engineers we all know that, but our project managers are telling us the complete opposite. Our project managers are either saying, don't do any documentation, that costs too much money, or they're saying, this is a medical project, we need to do every ream of documentation that has ever existed and we won't have any time to actually write any code, which is just horrible. So the first thing you do is have a project development plan, and the plan is when you sit down and you say, all right, these are all the things we can do, what should we do? What can we throw out? And that's really, at VI, our project managers have this attitude of they want to get rid of as much as they can, or as much as makes sense, because they don't want to spend money on things that aren't going to provide value to anyone. That said, there may be a situation where a requirements document has, the customer has no interest in that, but as a company it is very important to us because this customer is a little nebulous in what they're asking for. I mean, how many times does a customer come and say, here is the exact specification of everything we want, we've already made our UUT, it's completely done, it's ready to go to market, here, test it. No, I think maybe twice in my career that's happened. It's usually, well, it's a variant on an old thing that we made, and the firmware's going to be different, but don't worry about that, we'll give that to you later. And oh, we're going to add some channel count later as well, but they don't tell you about it. So a lot of that militant part, remember we're talking about practical stuff here, that theoretical stuff you kind of need to let go of. So, sit down, your project manager, your test manager, your test engineers, your developers, the customers, sit down and say, all right, what's important here? What can we rule out? You don't have to do everything. So the first thing you should do is identify the deliverables, the aids, and the artifacts that are required. Another thing that's kind of important here, and I'm going to be talking about a lot of stuff, is that, again, you don't need to do everything straight away either. What we recommend to some of our customers is to say, identify what's really important, and then identify the things that aren't quite as important but are still important. Start working on the really important stuff in this project. And then when you get to the next project, you've created a template for that thing, that artifact, or that aid, or that deliverable. And now we're at the next project. Look at the things that are kind of the next tier down of importance and start developing that one as well. We're not suggesting you should stop your company right now, spend a year working with consultants to get the perfect requirements template and the perfect design templates and those kind of things. There are companies out there that do make that suggestion. If you've got the cash flow, then yeah, go for it. But that's crazy for everything. So this is actually a map from one of our project development plans where we have all of our deliverables mapped out, and we sit around the table and say, don't need that, don't need that, don't need that, definitely need that, don't need that. So, and we show this to the customer. We show this is what you're going to get. And if we're wrong, let us know. If there are things here that we've said we don't think we need, then, and you think we do, let us know and we'll do them. And vice versa, if there's stuff here that we think you want, but you don't care about it, then let us know, we'll pick it up. So your major activities here, and this kind of covers through that the development models we talked about a little bit earlier, to define your user requirements, system requirements, subsystem requirements, develop your components, think about your unit and module testing, factory acceptance testing, delivery and installation, and site acceptance testing. That in a slide is basically the high level of what we all do. I'm not going to go through it, every single one of these. Identify what you have already, what things you've done from previous projects, what things you've made templates, and work out how they're actually going to fit into this execution. and identify what the deliverables are to the customer. Remember, you may do things that are important to you that aren't important to the customer. You don't want to flood them with too much information. You also don't want to give them too much ammunition. I mean that in the most positive way. And like I said, start capturing these things and turning into templates and forms. So you don't have to spend a week doing it. In fact, you can just take a copy of the document, put it in your source code repository with your template project, and even leave all the information in there. So it's a good example for people moving forward. Writing good requirements. This is, I mean, I could talk about this for weeks because it is such a pain in the, no, it's such an art form to do this right. But just starting with basic stuff. All testing starts with requirements. If you don't have requirements, you haven't written down some kind of specification, then how do you know what to test? If you don't have them, you haven't identified what's important to test. So learn how to write verifiable requirements. Requirements shall be requirements, not specifications. And a requirement, this is kind of the key one here, the requirement is only good if it's verifiable. And that's why when you're writing your requirements, you should be thinking about how am I going to test this? Because if you get to the end of the project and you have a requirement in there that you can't test, how do you deliver the product without the customer saying, but wait, what about this one? Unverifiable requirements, risk, schedule, and scope. So these are kind of the key words that you use in requirements. Remember I mentioned shall before. Shall is what to do, should is a recommendation on how to do it, will is more of a purpose or intention connection with the requirement, and may is a permissible action. A lot of people think you should only use shalls because they're the only things you should have to test, but requirements documents are very rarely that cut and dry. There's always a lot of intent that wants to be added in there as well. It's kind of better to push it down into design if you can, but there's nothing wrong with having it. Don't be frightened of having these extra things in requirements document if you don't have to have them. This is really the big important part here. Is like I said, plan how you're going to test your requirements while you're writing the requirements. There's nothing worse than waiting until you've been all the way down through here and you're about to deliver the customer the product. You're like, okay, now we need to write down some tests on how we're actually going to test to make sure that we did the right thing. Because you will find that you have not covered some of your requirements, and you will find that you have done a whole bunch of work that isn't in the requirements. Requirements and test plans are invariably intertwined. You should start with what must it do, and then think about how would I test that. If your customer is belligerent, who's had a belligerent customer? Come on. Never. Talk them through how you plan to test. I use the word plan quite specifically here because a lot of people here start talking about verification procedures. A plan is a higher level of that. It's like, are we going to inspect it? Are we going to demonstrate it? Is it similar to something else? I'll talk about that in a sec. You don't always need to take your customer through the complete procedure every step. You know, the operator does this, and then the operator presses that, and then verifies this happened. A lot of customers do want to see that, but you don't always have to do that. But at least have them on board for the plan, because this really helps you with the requirements. They may be asking for something that is unreasonable. Say, all right, we would probably test it this way. How do you think we should test it? And that's often a kind of a jumping off point with your relationship with the customer to be able to say, you know what, this is not a good requirement. Either we can't do it, or we need to rewrite it in a way that is more clear. So at the end, we have a happy customer, because that's what we're all here for, is to have a happy customer at the end. There's nothing worse. This happened to me about 10 years ago. There's nothing worse than delivering a test system, getting the vibe that everyone's happy, and then going back to that facility a year later to see your test system being used as a doorstop. This literally happened to me. It was also not a big system. Actually, literally, it wasn't a big system. It was about the size of a really good doorstop. And that, I died a little bit inside, because we all want to feel like what we're doing is benefiting the world and making people happy and making humanity better. And then you know what? It was doing a really good job keeping the door open. Okay, I get that. Okay, so a lot of people in the past 5 or 6 years have been talking about design for test. You need to design for verification. Plan the verification method for each requirement as you're going through this kind of stuff. It really helps you up front. Verification methods for the plan. Remember, when talking about the procedure, we're talking about the plan here. So inspection, that's a non-destructive examination using sensory inspection. That is a really cool way of just saying, look at it, measure it with a tape measure. I mean, occasionally you get a requirement that the system shall be it has a footprint requirement for a production floor. It shall be less than 70 inches by less than 70 inches. That's an example of that. Demonstration is manipulating and inspecting. Test is what we're mostly used to, which is where we have our predefined inputs. We run something and we compare the outputs to a known source. Analysis is comparing the predictive models and calculations to what actually comes out of the system. And similarity, if something's the same as something else that's already been verified, and that includes things that you've made, but also includes things that are off the shelf. If you're in a regulatory environment and you're beholden to the IEEE 9001 standard, similarity is a really neat way to do a verification, especially if you're buying something from a company that is already 9001 certified, like National Instruments. We don't have to prove to the customer that DAC card, the 8 channels acquire analog signal between -10 and 10 volts at whatever frequency, right? Because National Instruments, presumably because they are certified, have gone through the processes that are required to develop that piece of hardware that we can say that it's good. Most people get scared off testing a little bit because they only know about this guy. The only way to test something is through doing a physical test, but you have these other 4 here that make things a whole lot easier, especially inspection and demonstration. This is an example of a verification plan for a project that I worked on a few years ago. And you can see here we've got a table, we've got a requirement identification here. This is the way that we've picked that we're going to do the verification, the text of the requirement, and when we're actually going to do it. So you see here, all I've done is I've said inspection, demonstration. I haven't said how I'm going to do it. This is what we put in front of the customer and we talk them through it. It's a great way to get on the same page with the customer up front when you're writing requirements. Tools to help you do this. Who's using National Instruments Requirements Gateway product? One person. That's actually pretty good. That's a higher percentage than I usually get. Who here has heard of Requirements Gateway? That's about right. 4 or 5 people in the room. Requirements Gateway is a product that National Instruments purchased from IBM, I think, 6 or 7 years ago, and it's part of the developer suite. It's touted as a requirements management piece of software, but basically what it does is it has the ability to suck in your specification Word document and your requirements Word document and your design documents and your code and trace through where all the requirements are being met. So it's really more of a management tool than anything. It has some neat features built in, like rule checking, so I know if I've numbered 2 requirements with the same number, it will tell me about that. But the really important part is that it will say, like I can scan my project and it will say, okay, here are the requirements you currently say you're covering, and here are the ones that you haven't done yet. So it's super important for tracking through the project. Like I said, you can link specification to requirements, requirements to design, design to code, code to test plan to test results. I mean, if you want to go into that level of doing stuff as a check, we use this on probably 80% of our projects, even if the customer doesn't care about it. So at the end, we don't run our acceptance test and go, oh, what about that requirement? I totally forgot about that one. This one tells us whether we're covering something or whether we've noted we're covering something. And this is just a screenshot where it's actually scanned through a requirements document. It's our system requirement here, and it's found all of the verification are required, and we work with the customer to say, yes, we are going to do demonstration there. This project over this one, that the engineer said we're actually going to inspect that one and put in a test case ID there. Again, it just keeps us honest about what we're trying to do and keeps the customer happy. Unit testing. Who does unit testing? Everybody put your hands up. Everybody does unit testing. It's one of the awesome things about LabVIEW is that every chunk of code we write has got a front panel. Has inputs, has outputs, probably stuff on the connector pane. And like I said, we'll write a VI and we'll run it a bunch of times, more times than most people using other programming languages do, because they have to do linking and compiling and blah, blah, blah. We will have our little VI that adds 2 numbers together, and we never trust it. We never trust the primitives on the palette. We never trust our own code. We certainly don't trust other engineers' codes. So we'll run it. We'll make sure that that little plus thing is actually adding 2 numbers together. We'll drop probes down or whatever. That's ad hoc unit testing. It's easy. It's fun because it gives us confidence in that what we're doing works. And again, that's a great feeling, right? So this is your test-driven development. This is when you're actually developing things. You should be in the back of your mind saying, well, I've got to write this little module. I need to know that what it does is actually what it's supposed to do. How am I going to test it? Am I just going to run the VI with a couple of the input numbers, which is totally fine? Or am I going to use some sort of automated test tool? Unit testing, what is it? It's verifying that a component's functionality meets its goals. How do you choose what a component is? I do not have an answer for that. There is no answer for that. Only you can tell me what a component is. Sometimes it's clear that you're writing an API and that's a component, but other times, just in the back of your mind as a software engineer, you say, you know what, that little box of stuff over there, I need to run some tests on that. And there's nothing wrong with that. That's good too. The component's boundary must be well defined. You can't be confident in the results of a test if you don't know what outputs correspond to what inputs. Right? So you need to have the component boundaries. The inputs and the outputs need to be well defined. The ranges need to be well defined. The vectors need to be well defined. White box versus white box testing. And plan for regression testing. This one here is kind of important. So regression testing is going back and testing things again when something else has changed. Most of us work on teams of 2 or more people, or at least use components from other people, and those components can change. So your VI may work today, but then Frank might put something up into your source code repository maybe without you even knowing. And then in the morning you get there and you get all your code back down and suddenly your VI doesn't work anymore. So sometimes it makes sense if you do have components that are reliant on other components to say, I'm going to need to run this test more than once. And that may change your mind on whether you're just going to twiddle some inputs and outputs or you're going to implement some kind of automated testing. When should you do it? When the demand for quality is high. What does quality mean? Can anyone give me a definition of the word quality? Giving the customer what they expected? There are 2 definitions of the word quality. When you buy a quality laptop, your mind is thinking, it's good, it's going to do what I want it to do, right? It's not going to fall apart. In the early 80s, quality assurance people hijacked the word quality. It no longer means something good, it means something repeatable. As long as everyone you build is exactly the same as the previous other crap, that's high quality. So if your demand for quality is high, if it needs to be repeatable, then you need to start looking at unit testing. Again, make sure that the definitions of the input vectors give you the outputs that you expect. If the code component is modular, that's usually good, a little flag that pops up and say, hey, maybe I should do some unit testing here. If other parts of the system won't be ready in time, we talked earlier that you always get the UUT at the start of the project. Unit testing is great for that because you might put in a hardware abstraction layer or something like that that you can switch out for the real thing later. If you've unit tested your API and proved that all the inputs and outputs work and that the flow works in your piece of code, and then when something else comes online later, like I said earlier, if you've already got unit tests set up for that, then you can prove the quality of your API is good. If you have multiple developers on your team, obviously all coders are exactly the same and do the same type of coding, and you've never opened up someone else's block diagram and recoiled in horror. Notice I'm not showing any code during this presentation. There's a reason for that. If the end use scope isn't completely clear, if you're writing something that is going to be used on your project, but may be used on other projects in a way that you can't even imagine, then unit testing is a good place to be because you can write unit tests or you can do unit testing based on the functionality that you need that can be extensible to other applications. If the component will have a long life and it's intended for reuse, great time to think about unit testing. If the permutations of inputs and outputs are high, so rather than you sitting there for a day, incrementing that numeric, hitting run, yep, that one's right. Incrementing the numeric, hit run, yep, that one's right. If you have a lot of vectors where your input may have thousands of different values and you want to be able to test across all of those, unit testing is a great way to do that through some kind of automated tool. It's when you decide what to do it to, and this actually comes more from the mill aerospace world. It's been applied really well to the medical world as well. Anyone heard of an FMEA? Value Modes Effects Analysis? Great. So you can use the strategies that are used in FMEAs, both product and test system, and system-based FMEAs for unit testing as well. You can say in your mind, what will go wrong if this isn't tested and an issue gets through? Am I testing an implantable defibrillator where people are going to die? Or am I testing a Lego brick making machine where, you know what, a batch may be ruined, right? How often, if an issue occurs, how often will it happen? Let's talk about the Lego system. If one batch is ruined every year, you probably don't want to invest all the time and money into implementing some kind of fantastic unit testing protocol. But if every second batch is being ruined, that's a red flag. The failure detection is kind of a tricky one. How likely is the failure getting through going to be caught? And I don't mean it that you should try and not have the failure to be caught and say, oh no, it got caught, I better go and check that. It's actually, if, again, implantable defibrillators, if the failure gets through and it doesn't, and later down the line there's some other testing that happens that will catch that failure, then you may not need to do it further up the line. And dealer's choice, this is sometimes the most important one. Gut feel it. You're engineers. You're going to look at something and say, this is kind of shoddy. I want to be confident that this stuff is going to work, so I'm going to implement some unit testing here. That's the justification. I did a code smell. I've got a gut feel. We need to test this thing as well. FME, I already talked about this. It's a formal thing. Again, come and talk to me if you're more interested in the formal way of doing this kind of stuff. Super important, like I said, in mil-aero, becoming even more important in the medical world as well. Basically gives you scores of things. Okay, let's talk about tools. The NI unit test framework, anyone using it? One person. So you can see here in my project over here, I've created some really super complex VIs, add, subtract, multiply, divide. And there are these extra things here, and they're the LabVIEW unit tests, or the LabVIEW tests. And what you can do is you can say, I want to test this add VI, and I want to test it for this range of inputs for A, and I want to test it for this range of inputs for B, and then I want you to test every input of A with every input of B, and then give me a report. I'm going to tell you what I expect the outputs to be, and that could be a vector as well. You give me a report that everything worked okay. It's kind of neat because you can just right-click on your project and just say test all, and it'll zip through all your VIs and make sure that everything is still passing your tests. And you can define really complex vectors, and you can apply results of one test to another test and build up some really neat stuff. So you can use it in a very simple way where this, the add VI is a really simple way. It's got two inputs, it's got one output. You can do setup and teardown as well. So if you have a VI that you want to test, or a component that you want to test, where you really have to do a bunch of other stuff, maybe turn on some power supplies and do some physical stuff and create references to files or whatever, you can do that in this setup VI, and then pass that data across to your unit under test VI, and then have a teardown VI as well, which closes out your power supplies and the like. So that's a really neat tool, again, from National Instruments, totally integrated into LabVIEW. Works really well with the requirements gateway as well. So if I'm a technical lead on a project, I can run a report which will tell me, even if I'm not working on the project, how my developers are doing, what broke this morning, what broke when we did the source code control commit last night. And then you can see that there. It's actually got some test results here where it's a bunch of repetitions as well. JKI tester, anyone using that? One. So we've got one person for the unit test framework and one person for the JKI unit test. Yay. JKI is a company out in California. James Kring is the guy that set that company up. Really awesome LabVIEW guys. They created this toolkit. It's a free toolkit if you go to jki.net/labs. You have to do a little bit more to set stuff up in this guy. Like you have to do setups and teardowns, and it's an OO-based toolkit as well. But that's a really neat low-cost entry solution to this kind of thing. Automated unit testing. You saw back here where I could right-click on my project and say run all my tests. Both of these products also have APIs. So if you maybe want to write another VI that runs all of the tests under particular circumstances for your project, maybe it goes to your source code control repository at 2 a.m., checks out the latest version of all your stuff, runs all your tests, nice HTML formatted report that it emails to you in the morning so you can cry over your coffee because everything is broken and you're 3 days from launch. You can do it with these kind of guys, write your own scripts. Acceptance procedure, and this is really the one that most people think about when they think about testing the testers. This is your verification one here. You should be writing this one while you're doing this one. We already have our plan to meet all of our requirements, inspection, demonstration, similarity, those kind of things. This is where you're actually writing the recipe that whoever is going to be checking the system out is going to be following. Put the UUT on, scan the barcode, press this button, look for this, look for that. Did this pop up? Is the answer 42, whatever. The reason that we wait until development is because, honestly, we don't really know what we're doing at the requirement stage. We know what we're supposed to end up with, but we don't really know enough about the product, especially if it's another company's product, and how that will interact with our system. And during development, things will change. The customer will say, we've got a new version coming out, it's going to have more inputs. With a new version coming out, the analog inputs are going to be different ranges. And so writing the verification while you're doing requirements, the verification procedure while you're writing requirements, honestly is a waste of time, because you're going to get into kind of coming up this side of the V here, and you're going to say, I'm locked into this verification procedure that I wrote when I didn't really understand what we're doing. And you're going to start cutting corners and changing what you've made to meet the verification procedure, which is not the right way to do it. While you're down here, this is the best fun. I don't want to write this. I don't want to open Word. I've got Test Stand open, I've got LabVIEW open. I'm like puppies bounding through fields of alfalfa. I'm having a great time. So go back to your acceptance plan, review the plan with the developers. We wrote the acceptance plan, the inspection, demonstration, similarity, back when we didn't really know a lot about the UUT, we didn't really know a lot about the process. Is it still valid? Do we need to change it? Do we need to say, you know what, we really can't test this one, it's going to have to be inspection, or does it make more sense to do it that way? And do that with the other developers that have been working on those modules as well. Can it be done? Are the necessary hooks in place? And remember, we're doing this while it's in development, so if there is a result that you need to get out of the system that isn't currently exposed, you can still do it. It's still in development. Group each requirement into its testing type. They're the 5 that we talked about earlier. And create your formal method for signing each of them off. So that's your recipe with your test cases that someone's actually going to put a signature and a date next to each one of those. Have your customer sign off the procedure. We got agreement for them on the plan that this is really where the rubber meets the road. This is where at the end of the project, that if they stand there and say, no, you shall not pass, hopefully when we rarely have to be in that kind of situation, because we have a much better relationship with our customer than that. Because this may be your formal acceptance milestone. Some project managers consider it more important than the requirements, especially if it's tied to a payment. The acceptance procedure is what we often do at the factory before we ship it, and then we do it again on site. Super important. So when you're writing this procedure, start with the simple ones. For example, demonstration, measure it. Yep, this is the size of it, sign it off. Group all of these standard operations into one long test. Just imagine we're going to test one UUT, it's a perfect UUT, it passes, everything standard happens. We're going to do that in one big long test. You've probably now covered 60% of your requirements, maybe even 70. And then start grouping the non-standard things into small tests. You know what? We're going to inject a fault. We're going to unplug a power supply. We're going to put a UUT in there that isn't going to behave like we expect it to behave. And do each of those as smaller individual tests. Dry run the procedures. Please don't wait till the customer turns up to run your acceptance tests, because you will be halfway through them and need to rewrite them. Formally dry run the procedure before you sign off the execution. Like here I mentioned earlier, we have the FAT and the SAT, so the factory acceptance test and the site acceptance test. Does the FAT need to be customer witnessed? Are they the kind of people that maybe haven't worked with you before and they want to actually see it running in your facility before you ship it, in case there's something where they go, wait a minute, this isn't quite right? Is it a smaller version of the SAT? Maybe you don't have the facility items that you need to be able to do a SAT at that point. Typically our FATs and SATs are very, very close to each other. Have a template. We talked about the procedures, the aids, and the templates before. Have a template. Develop one for the next project that you're on, even if it's just a small one, and then build on it for each project, make it bigger and bigger. Tools that can help. Let's go back to Requirements Gateway. You can see here, but we've linked all of our documents together. We've got our requirements, our designs, our FMEAs. That's a subsystem design document, and what have you. And you can see here these graphical links of, well, I've got a test case where I've done 5 different things and that covers 10 different requirements. Great, I've covered my requirements and I can prove that. And customers love this stuff. You can show them a requirements traceability matrix. It gives you and the customer confidence that you're covering everything you need to cover. It lowers your engineering anxiety so that you can be more stressed about the code you're writing at 3 a.m. as opposed to have I covered all my requirements at 3 a.m. Okay, we're almost done. Questions to ask your test organization, and I mean this both, if you have a test organization that is within your company that's doing these kinds of things, or if you've engaged with another company like VI Engineering to do this, ask them, what stage of my product development is your sweet spot? Remember that big spiral? Are you really awesome during the R&D phases? Or are you really awesome at the production phases? And beware of the answer of like, we do everything. Because there are very few test organizations that I know where their sweet spot is the whole gargantuan everything. And that's a good one for the product manager to ask. The test infrastructure manager, describe your project development plan. Like I said at the start, you'll have all of these things that you can choose from. Do you do everything? No. Do you only do two things? How does that align to what's important to me as a customer? How does that align to what's important to me as a test engineer? These are things you should be asking yourself as well. And don't answer, I do everything, because you don't. I mean that in the most respectful and supportive way. Just don't delude yourself. Test engineer, what tangible testing are you good at? Again, beware of the we do everything. Are you really good at unit testing of code? Are you really good at unit testing of subsystems that are hardware based? Are you really good at final acceptance testing? Are you really good at final acceptance testing within my industry? A lot of people will say, yeah, we do acceptance test procedures, and we've been working in automotive for 20 years. And maybe the company is really good at that, but can they apply what they've learned in the automotive industry to a highly regulated industry like medical, like something where the FDA is going to come knocking? And that's one of the kind of things that we stand behind, is that especially with companies that don't have a lot of experience in the industry that they're going to start working in, a regulated one like FDA, we will come in and tell you what's important, but almost more importantly than that, we'll tell you what's not important. People tend to do too much or too little. They don't know where to put the value in. So you need to be able to identify where you are in the big picture. You need to be able to identify what you're really good at. You need to be able to identify what's important to you personally, what's important to your customer, and what's important to your company. They're really the kind of key things that will give you the foundation to know what to test and when to test. Thanks, everyone.